Hey YouTube, we're going to measure something on this engine called the deck clearance. It's important to compute the compression ratio, or actually in this case to be able to tell the Ross Piston Company how much of a dome I need on the top of the piston to get the compression ratio I want. Now what the tool used is a depth micrometer. The way it works is as you turn the thimble up here, the rod there protrudes further out away from the base reference surface, which has the grooves, and it gives you the depth of whatever you're measuring. So what I've done is I set it on this optical flat, and with my two fingers hold it down with reasonable pressure, reasonable force, and then turn it until it just contacts the flat. It's like it just becomes, yeah. And what I end up with is a reading of, this is, instead of setting the rods to 0, which is a pain, taking it apart and trying to get the 0 to be exact, what I do is just set it on the reference flat surface, and it's reading about 9/10 of 1,000. So I need to call it 1,000. I need to take off 1,000 from whatever reading I get here. Now the reading I want is from, I put the reference base across the block and then hold it square, and then I'm going to turn the thimble until I get a reading until it touches the piston. So I'm going to have to put the phone down, or maybe prop it up over here to do this. You might be able to see it still. Hold it down across the block and turn. What I get is I get 24. I get the reading of 1 revolution down, which is it was just reads 25. So really, the reading is 24 thousandths of an inch deck clearance. Yeah. Yep, 24 thousandths. So that is that 24 thousandths. The difference in height between this sitting down 24 thousandths forms, if you can imagine, a very, very, very short cylinder of a 3.75 inch diameter and 24 thousandths height. That cylinder will give 4 cc's, or 4.5, I think, and that is enough to make a difference in the calculation of the compression ratio. So I need to count that slight cylinder. The head gasket has a thickness of about 40 thousandths when it's bolted down, so that becomes another short cylinder of 3.75 inch diameter and 40 thousandths height, and that adds about 7 cubic centimeters. So between the two of these features, the deck clearance and the head gasket thickness, I'm looking at 11 or 12 cubic centimeters of volume, of space, of volume. Now that's in addition to the combustion chamber, which is about 70. I'll have to do that one after the machine shop gets done with it, after the valves are installed and it's been surfaced, all the spark plugs are installed, get a room. But all that should come out to be, I'm looking at about a dome of about 12 cc's to get my 11 point, well, at least 11.1 compression. So instead of this dish, it'll have it'll be a flat over with a pop-up, a slight dome, some sort of feature that takes up 12 cc's of volume. It'll be like the reverse of this piston. And they could actually do that. They could probably actually just make it flat and then make this D shape just slightly tall, and then cut out the valve reliefs. So Ross Pistons will know what to do. I'll tell them I need this much volume taken out, added to the piston top to get my compression ratio. And there's a calculator I have on a spreadsheet that basically you take the cylinder's volume, which in this engine's case is 706.5 cc's per cylinder. You add the combustion chamber volume and this volume here, this little volume we're talking about, the head gasket, plus the deck height volume, and that gives you the total volume. And then you divide that by just the deck height and the combustion chamber and the head gasket volume. So you basically do division by everything except the cylinder's volume. Now, that's for a flat top, if the piston were flat top. But the calculator I got shows that if I put the numbers in, that won't give you enough compression. So I need to figure out, well, how much of a dome do I need? How much of the dome do I need in the piston? Because what that does in the calculation is, as you reverse this dish and you put a dome, you end up with slightly less on the numerator, because the cylinder volume is 706.5 minus that dome, which is a change to the numerator, but it involves a large number, like 780 cc's total. And then on the denominator, you subtract that 12 from the combustion chamber, head gasket, and deck clearance volume, and the numerator becomes quite a bit smaller proportionally, and you end up with a higher, basically it is about a higher compression ratio. This dish is the reverse. This dish adds volume on the numerator, but it also adds volume on the denominator. It adds the same volume, and that affects the denominator more, and you end up with like 8.5 to 1 compression. So I think flat tops would give 10.5, close to 11, maybe close to 11, 10.9, but I want at least 11. So I'm going to need a dome on the piston, and that'll give me my compression ratio. Typical high performance engines from the past, they always had they called pop-ups. The piston, that dome I'm talking about that will be on the pistons, is called a pop-up pistons. That was the kind of piston you needed to get your compression up. Another way to do it is to reduce the volume of the combustion chamber. You could use a very thin head gasket and reduce the volume between the head gasket and the deck clearance. Because right now I'm looking at about 60 thousandths. I mean, I could afford, you could deck the block, you could shave the block down to get that volume to be 0, or make that deck clearance 0. You could get the piston. I might ask Ross if they could increase the what's called the pin height, increase the compression height of the piston by 25 thousandths. Basically move the wrist pin in the piston. That would be moved downward, which would push the top of the piston upward effectively. So that's one way. Maybe I'll help them do that. That'll be my pop-up piston, maybe less. I think even with flat tops, if I do that, it would be pretty close to 11 to 1, pretty close. So that's the deal. Depth micrometer across the block, measuring the cleaned off piston. Optical flat, you don't need an flat, you use any flat surface like a countertop may do, but I just happen to have this flat. And that's it. Just FYI, how to do deck clearance measurement. And the computation is, for any of these, is the diameter squared divided by, times pi, divided by 4. So roughly 3/4 of the diameter squared. And times the height. And these heights are very shallow, like this is 25 thousandths, 24 thousandths, 40 thousandths for the head gasket. So they're very, very, very short cylinders, but the formula for computing volume of cylinder applies. Thank you, YouTube. Bye-bye.